Okay, in example 1.18, what we're going to do is we're going to apply theorem 1.2 to find the continuity of various polynomial and rational functions. So the first bullet says that a polynomial is continuous at every real number. So there's really nothing to worry about if you see a polynomial like g of x equals x squared minus 2. That looks something like this. We know this is going to be continuous everywhere on the real line. So this is continuous everywhere. Now 2 says a rational function is continuous at every real number in its domain, and so that means every real number where the polynomials or the rational function is defined, it'll be continuous. So for y equals 1 over x, or f of x equals 1 over x, that looks something like this, and it's defined everywhere except for at x equals 0. So this is continuous everywhere except where the denominator equals 0. So except where x equals 0. Okay. And so there you see you have a jump discontinuity at x equals 0. Now, h of x equals 1 over x squared plus 1. It's continuous everywhere where the rational function is defined, so everywhere except where x squared plus 1 equals 0. But when does x squared plus 1 equal 0? That would be when x squared equals negative 1, which would be where x is equal to plus or minus the imaginary number, the square root of negative 1, so it's plus or minus I. And so it's continuous at all real numbers. And so if I graph this, it actually looks something like this. So here's a rational function that's also continuous everywhere. So to summarize, if you have a polynomial, it's definitely going to be continuous everywhere. If you have a rational function, it's going to be continuous everywhere except for where the denominator is equal to 0.